Hello everyone, welcome to my channel. So today we will learn about abrupt PN junction. While we calculating our different values of like electric field and all that, we need to focus on this depletion region. That is, you can see it is minus xp on the p side, xn on the n side, and we are only figuring uh, a way to calculate what is the charge density, what is the electric field in this region, what is the potential in this region. So we are only targeting this area. And what is abrupt? Abrupt means the you can see that on the p side we have na acceptorance. So acceptorance changes from na to 0 at x is equal to 0. It abruptly changes to 0, and similarly at x is equal to 0 it changes abruptly to nd. Well, that is only an assumption to solve our equations. This is not practical. Actually, this cannot happen abrupt or sudden. Okay. Now coming back to the charge density plot, which is rho v, and it is actually minus. The acceptor ions are negative, so it can be written as minus qna coulomb per centimeter cube. Why? Because it is charge density. Okay, and it is within this region minus xp to 0. Okay, and what is about this positive charge density? This is from 0 to xn, and it can be written as plus qnd coulomb per centimeter cube. Now what about if we want to get a charge here? So we want to get charge here qd plus, we want to obtain charge here qd minus. How we can get that? Because if we multiply this by the volume, we can get the charge. Okay, so in coulomb, qd plus can be written as qnd a into xn, as you can see, and qd minus is given by minus qna a into xp. Area into xn is the volume. So centimeter cube will be cancelled, and we get charge in coulomb. And what is total charge neutrality or electrical neutrality? It means the magnitude of the positive charge and magnitude of the negative charge should be equal. So when we equate these two equations, we get a very important formula, because q and a will be cancelled out on both sides, and we get nd into xn is equal to na into xp. And this formula is very useful in various examination. Okay, now we come to the electric field and potential distribution, and we know the Poisson's equation. Basically it is del E by del x is equal to rho v by epsilon, or del square v by del x square is equal to minus rho v by epsilon, or we can simply write electric field is equal to integration of this rho v by epsilon dx. Here rho v is the charge density, epsilon is the permittivity. Now in P region, that is, if we want to calculate our electric field in P region, so we know the value of rho v, it is minus qna, we have already seen that, and we will put this in our equation, which is rho v by epsilon, and we get minus qna by epsilon dx. So if we integrate it, so we are only putting electric field as a function of x, so we have written ex, and this will be coming as x, and now there will be some constant. So how can we obtain this constant c1? Okay, so for understanding the boundary condition, you need to see this figure, and in this figure at minus xp the electric field is 0. Okay, so why is that so? Because beside that we are taking here quasi neutral region where electric field is 0, and we only get electric field here in the depletion region. So that is our one thing. So that is what we are doing to get the constant c1. Okay, So here you can see we have put it 0 and x in the place of x we have written minus xp, and therefore we will get the value of c1. Then our whole equation e as a function of x will become minus qna epsilon x minus qna epsilon xp, or you can write it as minus qna epsilon x plus xp. This is like the equation of a straight line, and here you will get the slope also. Okay, what happens when we put x is equal to 0? Then we will get the maximum electric field, that is E naught. This formula is also very important, minus q n a x p by epsilon. This is very important, but this is for p region. What is for n region? N region, again you put the value of rho v here as q n d, and then you integrate it and then apply the boundary condition, find the value of C2 here, and then C2 will come when you put x as xn and you put electric field as 0, and C2 will be coming like this, minus qnd xn by epsilon, and put the value of C2 in equation 2, which we have written as Ex is equal to q n dx by epsilon plus C2, and then you will get this formula. This is from 0 say 0 to xn. Okay, so this is also like a equation of a straight line. Here you will get the slope also, which is q n d by epsilon, and also you can get the maximum electric field when you put x is equal to 0. So what does the plot look like? This is the summary. We need to see the plot to understand it fully. So first one is the charge density plot. We have already seen it. Here it is plus, here it is minus. Now we need to see the electric field curve. We can also derive it at when x is equal to 0. This point is x is equal to 0, and this is our maximum electric field. And there is a task for you. You can also derive the value of voltage, which is here. Okay, so it is actually, it can be calculated from this Ex is equal to minus dv by dx, where Vx is the integration of Ex dx with a negative sign, and the voltage curve will be something like that. This is a basic PN junction plot and derivation for electric field uh, and also the maximum electric field at x is equal to 0. So if you like this video, please like, share and subscribe my channel. Thank you.